Hey, welcome back to Math with Patrick. It's April 30th, and we're solving problem number 120 from the Daily Epsilon calendar. And apparently, the answer is 30, because it's today's date. And we need to show why the greatest common divisor of 7,410 and 2,310 is 30. So a little bit of vocab, a divisor is just a number that divides another evenly. So here you can see that 2 is a divisor of 6. 6 is a divisor of 36 because it divides it evenly. And then 2 is not a divisor of 7 because it does not divide it evenly. When we're talking about common divisors, that just means we got two numbers and they have a divisor in common. So 10 and 20 both have a common divisor of 2. They have a common divisor of 5. But then their greatest common divisor, as in divides both, and it's the biggest one of all the numbers that divide both, is going to be 10 here. So sometimes the GCD, or greatest common divisor, of two numbers might just be one of the numbers. So my plan here is to figure out some divisors, or factors, actually, that's another word for them, of these two numbers, and just figure out what they have in common. So for starters, I notice both of these are divisible by 10. 10 times 741 gives me the above number, and 10 times 231 gives me the above number as well. And so far, I know right here that they have a common divisor of 10, but I'm not sure if it's the greatest yet. I might still find another number out there that divides them both that's bigger than 10. Of course, you can see that it's 30, but let's show why that is. There's a divisibility trick that you can do with the number 3. If the digits of a number sum to something that's divisible by 3, then that tells you that the original number is divisible by 3. And so both of these numbers, 741 and 231, both of these numbers kind of follow that idea where if you sum the digits and you get a number that's divisible by 3, then the original one is as well. So that means it's worthwhile for me to go and check with long division, hey, how many times actually does 3 go into 741? I'll also check how many times does 3 go into 231. All right, goes into 7 twice. I'll subtract that out. I'll bring down the 4. Goes into 14 4 times, because that makes it 12, and I'll subtract that out again. And 3 goes into 21 7 times. Cool. So let me kind of declutter this a little bit. Basically, I just figured out that 3 times 247 is 741. And so I can break it up like this. And I'll circle this in green right now just to kind of say, hey, cool, look, I found a common factor of 3 here. I know there's going to be a 3 over here somewhere. I just got to figure out how that 231 splits. 3 goes into 23 7 times, right? Because that makes it 21. And then 3 goes into 21 7 times again. So this is going to be 77 times 3. Okay, and then I'm erasing all of my hard work with that long division because I just need some more room. So this 77 right here is probably easier. Well, at least it's definitely easier for me to find factors of. I know that 77 is 7 times 11. And then also these are both prime. I'm going to box them in red just because I'm pretty sure I won't find a 7 and I won't find an 11 over on this side. Let's see if we can factor 247. If I add up the digits, I get 2 plus 4 plus 7, and that gives me a 13. And so this is not divisible by 3. It's not divisible by 5 because it does not end in a 0 or a 5. I should show that it's not divisible by 7. Let's see. Okay, let's see. I do know that 7 goes into 49. And if I count by my 49s, I should get kind of close to 247, but I think I'll miss it. 49, 98, 147. I'm like basically counting by my 50s here, but then I'm subtracting 1 each time. And then so the next one will be 245. Okay, so that tells me that 7 does not go into 247. The next prime to check is 11. And let me just kind of count up by some multiples of 11 until I reach around 247. Okay, that wasn't that hard, because then the next would be 253. Okay, so since 247 is in between these two numbers, and since 247 is in between these two numbers, I know that 7 doesn't go into 247 evenly, nor does 11. So I actually don't know if 247 is prime or not. I'm not sure if I could keep breaking it down and finding more factors, but I did at least show that 7 won't go in there evenly, nor 11. And that means I will no longer have any other factors or divisors. It's kind of mean the same thing. I won't have any more shared divisors here. And so since I found a 3 and a 10, if I multiply these together, I will get the greatest common divisor of these two numbers, and it's going to be a 30 for today. So there we go. We're all done, and it seems like using factor trees and divisibility rules was the way to go to figure out the greatest common divisor. And it's 30, and that's today's date. So I'm all done, and I guess I'll see you next month. All right, bye.